So hello students, in this class we'll start a new chapter, integers. In previous chapter we have completed the numbers. Now we'll start the top chapter, integers. So to start the chapter integers we need to know what are natural numbers and whole numbers, which I have already taught you. Just giving you a recap. The numbers of from 1, 2, 3, 4 up to infinity are called natural numbers, and it is denoted, the set of natural numbers is denoted by the letter capital L, like this. Again, the numbers are from 0, 1, 2, 3, 4 up to infinity are called the whole numbers, where they are denoted, the set of whole numbers is denoted by the letter capital W, and capital W. So you can clearly see, if we add 0 with the set of natural numbers, then we will get the set of whole numbers. Next, the set of integer is denoted by Z. Now, when we see the set of the collection of natural numbers like 1, 2, 3, 4, or the collection of whole numbers 0, 1, 2, 3, 4, we don't get any negative concept of negative numbers or like that. But in this set of integers, the number of from the both positive and negative numbers comes, which can find both. But in the set of integers we can find both positive and negative numbers. So the number of from -3, -2, -1, 0, 1, 2, 3 here up to infinity, and from minus infinity to all called set of integers. To be more specific, obviously minus infinity plus infinity are not integers. This is higher concepts. Whatever. The set of the numbers of from 1, 2, 3, 4, 5 are called positive integers, and it is denoted by the set Z plus. The set of positive negative integers is denoted by Z minus, and the numbers are obviously from -1, -2, -3. These are all negative integers. We have to remember one thing, that 0 is not either positive or negative integer. Now, zero, no, 0, 1, 2, 3, 4, 5, these are all called non-negative integers. I add 0 with set of all positive integers, and this gives me a set of all non-negative integers. Similarly, if I add 0 with set of non-negative integers, then we will get set of non-positive integers, and the numbers will be of like this: 0, -1, -2, -3 up to infinity, to minus infinity, and here this number is tending to plus infinity. Next topic which comes in the chapter integers is number line. So we can, I draw a point 0, a point which will, so in the middle of the straight line and draw a point which will denote the point 0. Then I go to unit distance at right and draw a point. This will show the value of point 1 in the number line. Same way I go right to another unit distance in the right. This will show the value of plus 2 in the number line, and if I do so on, I will get plus 3 plus 4. And similarly, if I go to the left unit, similarly I will go to left from 0 unit distance and I will get minus 1. Unit distance from minus 1 to the left where I will get minus 2, and so on. Note that I am always saying that word unit distance, because when you will have to draw a number line in the exams for any exam purpose, you have to draw it with a proper scaling, or else the numbers will be reducted. Now some important notes. All positive integers lie to the right of the number 0, and all negative integers lie to the left of 0. So if we see the number line, we can clearly see all the positive numbers 1, 2, 3, 4 are lying right to 0, and all the negative numbers lying left to 0. No positive numbers present in the left of the 0, no negative numbers present in the right of the 0. Now the next point, any integer lying on the right of another integer is greater than that integer. So if I explain it, I draw a number line 1, 2, 3, 4, minus 1, minus 2, like this. See, minus 1 is greater than minus 2, minus 0 is greater than minus 2, 1 is greater than 0, 3 is greater than 2, minus 1 is greater than minus 3, and so on. And if I go to left, if a number lies on the left of a integer, then if an integer lies on the left of an integer, then that will be less, like minus 1 is less than 0, 1 is less than 3, and so on. The next important topic is finding successors and predecessors of an integer. To find a successor, we simply add 1 with the integer. Example 4, if the given integer is 4, then to get the successor we just do 4 plus 1 and we'll get 5. This is the successor. 5 is the successor of the integer 4. Similarly, if the given integer is minus 2, we just add to get the successor, we get add this plus 1, we'll get minus 1. So minus 1 is the successor of the 2. So minus 1 is the successor of minus 2. To be more accurate, we can draw a number line. If we have to be more accurate means if we're having problem in adding 1 with an integer, we can draw a number line and just check exactly the number in the right of the given integer. Like if I given 1, I just look for the rightmost number, which is 2, which will so 2 will be successor of 1. Same. So now we have to know how do we find predecessor of an integer. To do that is simply subtract 1 with the given integer or add minus 1. Example, if the given integer is for form, like if the given integer is 4, then we just subtract, to get the predecessor we just subtract minus 1, which implies 4 minus 1 equals to 3. So 3 will become the predecessor of the integer 4. Similarly, if the given integer is minus 5, to get the predecessor we just minus 1 from 5 and get minus 6. So minus 6 will be the predecessor of the integer minus 5. Important point. You have to remember an important point. The successor of the predecessor of an integer is the integer itself. If I have to give an example, if I have to explain this by an example, let me show this by an example. Let I have been given the integer 5. Then to get the successor of 5, I just add 5 plus 1 and get 6. Now the predecessor of that integer is 6 minus 1 equals to 5. So I am getting back the number 5. So which I have been already given. So I am getting the integer which I have been given. So the statement is valid. The statement the successor of the predecessor of an integer is becoming valid. Next, some important points for doing some maths. The number of integers between minus a and a is 2a minus 1. Let me just explain this by an example. Now let the given numbers be minus 2 and plus 2. Then the number of integers lying between minus 2 and plus 2 will be 2 into the number 2 minus 1 equals to minus 1 3. Or let the given numbers be minus 3 and 3. So the number of integers between minus 3 and 3 will be 3. 2 into 3 minus 1 equals to 2 minus 7 is 5. If I have to check this, the number of between minus 3 and 3 are minus 2, minus 1, 0, 1, 2. So how many integers are there? 1, 2, 3, 4, 5 and 5. So there are 5 integers between minus 3 and plus 3. The next point, the sum of all integers between -1 and -a and a is 0, where a is an integer. Now I am showing this by an example. Let the given numbers be -4 and 4. So the integers between -4 and +4 are -3, -2, -1, 0, 1, 2, 3. If I simply add them, what will happen? Let's see. -3, -2, -1 plus 0 plus 1 plus 2 plus 3. -3 -3 cancels out, -2 -2 cancels out, -1 +1 cancels out, and what will get? 0. So our given statement is valid. Similarly, the product of all the integers between -a and a is 0, where a is an integer. Let me explain this by a number line. In a number line, let there are two integers -1 and 1, or -3 and 3. I can clearly see there is a 0 in between any -a and +a, or any integer from -a or +a. So if I product all the integers 0, so our given statement is valid. Next topic is absolute value of an integer. Let me first give definition of it. The absolute value of an integer is its numerical value. It does not depend on its sign. Some examples: absolute value of -2 and 2 is 2. Absolute value of -3 and 3 is 3. Absolute value of -10 and 10 is 10. To find absolute value of a number, we use the modulus sign, which is like this. Modulus of any negative integer returns back the positive integer. Modulus of any positive integer is that number itself, and we know 0 is neither negative nor positive. So modulus of 0 will remain 0. It will neither give a positive number or a negative number. So here ends our introduction class of the chapter integer for Maths Olympiads. In next class we'll discuss furthermore some theoretical part and get into the numerical portions for the Math Olympiads. Thank you. If I wish to check the number of integers between -3 and 3, I can check like this: the integers